In chapter 10 we start looking at probability again, and there's something called the gambler's fallacy. And essentially what it says is that if you're doing really bad for a long time, essentially you're due to win. But that's not true, because your, for lack of a better word, luck has no bearing on probability. When you flip a coin, if you hit 3 tails in a row, should you expect that a head is more likely on the next one? No. Even though you got 3 tails in a row, and you're expecting that half of them will be tails and half will be heads, that fourth flip, the probability of getting heads is still 1/2. Likewise, if you have 5 heads in a row, should you expect that a tail is more likely? No, there also. It doesn't matter what happens previous to the game that you are currently playing, the turn you're currently on, the flip of the coin that you're currently on. The previous flips have no bearing on how you can do on the current flip of this coin. So some definitions. Experimental data is data that is collected. Through doing something. For instance, if I was going to collect experimental data on flipping heads and tails, I would take a coin and flip it 20 times and write down what I get each time. Theoretical data is what we expect to happen. This is data that is generated based on the laws of probability. It's not the result of doing an experiment. A few more vocab terms. Outcomes are the results of doing something. The outcomes of flipping a coin are heads or tails. Outcomes of rolling a dice is getting 1, 2, 3, 4, 5, or 6. They're the results of doing something, or the results of doing an event. An event is what you do to create data, what you're experimenting with. And there are 2 types of events: simple events and compound events. A simple event is just one thing happening. For instance, flipping a coin or rolling a dice. A compound event is 2 or more things happening. So in this kind of event, you're dealing with flipping a coin and rolling a dice, or rolling 2 die, things of that nature. But it's 2 or more events, 2 or more things happening at once in one experiment. So experimental probability and theoretical probability are 2 slightly different things. The probability of event E experimentally is found as the number of times E occurs divided by the number of trials. So if I wanted the probability of getting heads, I could flip the coin 20 times total, and if I got heads 17 times, the experimental probability of getting heads is 17 out of 20. The theoretical probability of any outcome E is found by taking the number of ways E can occur can being the operative word here, as opposed to maybe does occur up in this top one, divided by the total possible outcomes. So for the experimental probability of getting heads, well, there are two possible outcomes, and there's only one way you can get heads. The experimental probability is 1/2. It has nothing to do with any experiment that I do. It's theoretical. Experimental probability can be anything. It depends on what you get as results. Theoretical probability is completely dependent on the situation. And a different sort of interpretation we can do with probability is geometric probability. We can look at a geometric shape such as a skee-ball board, and we can figure out the probability of landing the skee ball in the 50-point circle. And with geometric probability, what we're assuming is that any space on the game board is equally likely to be hit. So what we do here, a success, the ways we can get a 50, well, that's going to be inside this circle, or an area of pi times radius squared, pi times 10 squared. And then the total possible area that we could land in is made up of two separate figures, a box and a semicircle. And that box has an area of 80 times 60 plus the area of the semicircle that has a radius of 30. Then to figure out the probability, we're going to go to a calculator probably. So I'm going to do pi, and use the pi button, don't use 3.14, times 10 squared, and I know that's 100, so I'm just going to type 100, divided by, now it's very important because we have more than one thing in the denominator that we use parentheses. 80 times 60 plus pi times 30 squared. Push enter. And this is where it's helpful to actually have what you're typing in readily available to you, because I forgot the 1/2. So I'm going to show you a little trick with the calculator, and this is kind of useful that I made a mistake. I push second and then enter, and it recalls the last thing I typed in. And I can press the left arrow to move myself onto the pi, and now I want to insert something, so I'm going to hit second and then the delete key that gives insert. Now the pi is flashing up and down. Anything I type in will go right before the pi, so I'm going to hit in 0.5 for 1/2. Now I push enter, and so my probability is 0.05055 yada yada. So this is approximately 0.051. So about 5% of the time we would hit the 50-point circle, which essentially says that it's about 1 in 20 if we're randomly throwing balls into the scoring zone. So here is the assignment for 10-1. Remember that probability is the ways you can get what you want divided by the total possible that you could theoretically have.